Hey, welcome back. We're doing final assembly part 7. We have you just saw the accessory drive. That was the last video showing the installation of the accessory drive and the exciting first spin up of this engine using the starter to spin the engine and see how smoothly things would rotate. And it looked pretty good, sounded pretty good. Okay, well, this video is going to show you a little bit more installation now, starting of the fuel lines, plumbing, tubing, whatever you want to call it. There's quite a combination of some stainless steel braided lines and a lot of aluminum, tubing with AN fittings. So in this video we're going to start installing plumbing, show you some clips of that, and I've had a couple of days off work where we were in between a couple of jobs, so I've had time to spend maybe a couple full days on this. So I made a little bit of progress, and that's a good thing. So I'm going to try to show you that in these increments. Also, we'll go ahead and show you a second spool up video where I actually ran it up and got a couple different views of that. It's starting to come together, and so we're excited about that. I'm looking forward to doing our field test. I'm a little anxious and a little apprehensive because this is very old equipment. The fuel control, fuel pump, that rubber is probably, honestly, it could have been rebuilt at some time in the 50s, but it was originally made in 1954. So, as we all know, rubber becomes dry and non-pliable, starts leaking. All right, so we're hoping not to have to do a whole lot of leak fixing, but it is what it is. Okay, so here we go. Let's show you some of the plumbing, and then we'll come back and then we'll rotate over to another spin-up test, show you a little bit of that, and let's see what else we can squeeze in this video. Not making it too long, because then we're going to progress to installation to wrapping up the fuel system plumbing, and then testing for leaks. That will be exciting. Here we go. All right, we got some work done, got some completion going on. Got all the fuel lines installed, and tubing, all the plumbing. This is the fuel inlet and so on. Okay, so you can see that there are a few pipes to run back and forth, and it just takes a minute to piece it all together, one big puzzle. So I'm making a little progress. I want to keep track of it here with the video update. Keep you updated. I just spared everybody the boring time of watching. The booster pump will pump fuel to this point, which is the fuel inlet to the engine. And this is almost like a manifold. As you can see, it has a couple of fittings and connections. It attaches to the intake housing at this point, and then there's an O-ring inside there. We have this aluminum tube, and this is the inlet to the fuel pump, the main pump. From there, it is pumped to, let's see, from there it is pumped through this pipe, comes around here to this T. This is a pressure checkpoint, a test point. You would connect a pressure gauge here. This would be the pressure from the outlet of the pump, main pump. But basically that's capped off, and for engine running use, fuel is piped through the filter. From there, it pipes through this tubing to the other side. This is the inlet to the fuel control and governor. After being controlled, what's metered, the scheduled fuel metered amount of fuel outlet for engine power setting, is then piped back through another line parallel here. But this one takes a turn downward, and honestly it travels, as you can see, around the engine, around the intake housing, and of course you know where it goes because you've been watching these videos, right? Follow me from the beginning. Comes right in here. It's the inlet to our acceleration limiter. This is a fuel flow control valve, fuel flow control. It's actuated in relation to compressor outlet pressure, which is a in direct proportion to its RPM and other engine conditions. This is what limits how much fuel can be slammed to the engine, even though the fuel is scheduled for a higher power setting. This limits how fast it can accelerate. If you try to accelerate too fast, these type of engines, as simple as they are, will have a compressor stall or surge problem, and this prevents the surge. If that is not set right, you can get a surge, according to the service manual. This is a return line. This braided stainless steel braided flex hose, it goes back to the inlet. The fuel flow out of the acceleration limiter goes through this short pipe to the fuel cutoff valve. Since this is a T, it has a connection to a small line that travels back to the fuel control. So this is referencing back to the fuel control, the outlet pressure that's actually being delivered to the fuel valve and the fuel manifold. For whatever reason, that you fuel control guys probably can explain that better than me. This is all black magic here. This all here. If it ever goes haywire, I'm going to be probably not too happy, because there's not too many of those laying around. All right, you can see we're at the business end here of it's the business end of the fuel cutoff valve. Fuel cutoff valve. This is a sliding valve that will either, when it is closed, your fuel inlet is right here on this side from the acceleration limiter. That will be bypassed through a slider valve to a return line, which is right there, as you can see, straight ahead right there. That small line, that's a return line. So if the engine's motoring down and spinning, there's still fluid flow, the pump's still turning, that allows a path, a fuel can flow there. And at the same time, this outlet of the fuel flow valve goes to, there is the inlet to our fuel manifold. And there is a flex hose that connects from the outlet of the fuel cutoff valve to the inlet of the fuel manifold. So when the valve's closed, this fuel manifold is actually connected to a drain, which at the moment I have a plug in, and it's right here in the bottom of the fuel cutoff valve. That will drain and return any excess fuel back to our tank. When the valve is opened and it's energized, it is opened, and then at that point it basically connects this inlet to straight across and through to the outlet, which goes to the manifold, and it blocks off the return line and it blocks off the drain line. So this is a multi-purpose important piece. Allowing it to bleed off instead of drain into the combustion chamber, it reduces the hot start factor and excess torching when you start, because many times there's fuel left from the previous run if you don't bleed it away and you got a big torch. Okay, well, there's the update on the fuel system. So as you saw in the last video, we had installed the accessory drive and then started installing our accessories, literally. Well, now we've got them all plumbed. What's left here will be electrical wiring for the tach generator, the starter, and our actuator, which is our power setting actuator. Let's see, then we're going to move around to here. We have the oil mist lubricator, which produces our oil fog to lubricate the bearings. That has to be wired. It needs 28 volt. It needs 28 volt power. And we got plumbing here to attach our oil mist lubricator system to our compressor bearing. And then we have the pipes that go back here to our connections to our turbine bearing. Now, just to show you this, way back when, I think Jay had pointed out that the engine was originally bolted down front and rear firmly to the stand. He pointed out the possibility of expansion, thermal expansion, when you run it. When I started thinking, okay, yeah, that makes total sense. So Mark and I talked, and here's what he came up with. Machine slots. These were originally drilled with just round holes, or made with just round holes. So he took them back and they machined these into slots, and we use shoulder bolts which stop and bottom out and tighten, but yet they're not completely tight. And this is a spring washer, and I used a stack of 2 flat washers to put just some tension on it, and that keeps this from bouncing around, but yet this basically can still move forward and backward however much it needs. As you can see, it's got quite a bit of room for freedom. So I wanted to show you that. Agent JZ pointed that out way back 2 years ago in my running this, and when he saw. Basically, we're using a shoulder bolt, I guess you would call that a screw, but special purpose screw. And this, what you can see, this goes clear through and it'll bottom out onto the stand, but yet it'll leave enough space that just to allow this engine mount to move forward and backward. And then we have a wavy or spring washer. If you'll look, it has a little crown to it. So this has a little bit of a spring tension on it. Okay, so that holds down with some spring tension, yet this can still move ever so slightly as it needs. So there's a solution to a problem. Okay, let's go ahead and now take a look at another spin up. We'll see what, I'll show you my tachometer, or a percent RPM indicator, as it is technically known is a percent RPM indicator. The starter at full power, full spinning speed is exactly about 10% RPM, or about 1550 RPM. And that's levels off. It won't turn any faster than that under the battery power. Okay, so take a quick look at that of spinning her up. We'll do a rear view and a front view. How's that? So stand by. Okay, so here we go. Let's spool it up to full speed at 24 volts, 2 batteries and everything. So here we go. Rear view. Alright, there you go. Things turning pretty good, blowing all the flags around in the garage, and I think I apologized in the video if I didn't. Pretty sure. And I again apologize, Jay. Sorry, the Canadian flag got tossed about a little bit, but we fixed it right up. So we have, now take a quick look here. I got the oil mist lubricator heater wiring complete and connected, so that was another little bit of progress. Also got the oil lines, the oil mist lubrication lines installed, and the turbine bearing air cooling line installed. So we'll show you that right now. Okay, we got our pointing stick. This is the outlet, the outlet from the oil mist lubricator, which, as you know, is mounted inside of our housing and chamber behind the compressor. And it directs the oil mist, it generates up to this flange, and then it tees off. Obviously, it goes to the front, and you can see this is to the front of the compressor, and here's the compressor bearing. Okay, and then we also follow this line here, and it follows itself back here. And this connects to the turbine bearing oil mist nozzle, which a little nozzle that directs the mist right at the bearings. And okay, and then this is our turbine bearing air cooling line, which just bleeds some air off the compressor. And follow that line, and again it connects. And if you go back and review the exhaust nozzle housing assembly, it will show you where these lines connect internally to the turbine bearing. This is our electrical connection. This T goes this direction. There's a seal here in this little 90, and that brings two leads out. The leads are connected to an internal heating system, a heater and thermostat, to control it and maintain a certain warmth. I don't know exactly what that temperature is, but it maintains a temperature to help the oil vaporize. This is our Cannon or circular connector, 2 pins. Obviously this lead brings power from our electrical cabinet, which is down here below. Alright, so our lubrication system is complete, and I've put oil in it. Under theory, when the engine's running, the bleed air from compressor, not this bleed air, but internally there's some bleed air from after the compressor, after the diffuser, pressurizes our oil mist container and creates the mist, blowing it through an orifice, and it pipes it to the bearings. Well, there you go. We're going to go ahead and cut this one short and stop. We'll go ahead and I'll work on another video upcoming to we'll show you a continuation of the fuel system plumbing and eventually leak testing. Alright, I appreciate your interest, appreciate your comments, your viewership. Thanks, and I guess stand by. We'll get some more video out here soon. Appreciate it. You have a good one. See you next time.